So there is another reaction which they can ask. It's the reaction of lead nitrate being heated. They'll ask you, what can you observe when lead nitrate is heated? What color change can you observe? What color gas is evolved? These type of questions are very common. So the reaction is lead nitrate, when heated, it decomposes and it forms lead oxide, nitrogen dioxide gas and oxygen gas. This is the reaction. So balance this reaction. Try balancing it yourself first. Okay, so you see, this is the most complicated compound. Lead is already balanced, Pb1, Pb1. Nitrogen over here is 2. Now listen, in this case NO3, as in the other case, we can't take NO3 as one unit, because here NO3 is not remaining NO3, it's breaking up into NO2O. So in this case we'll have to deal with the elements separately. So here nitrogen is N into 2, so it's N2. Here there is only one nitrogen, so make this 2 first. Then again here there is 6 oxygen, okay, 6 oxygen, and here 4, 6, 7 oxygen. So what to do with this? There is 7 oxygen over here. So you know, this is an odd number and this is an even number. So first try to make this even rather than making it 6. Now see, in these compounds you have oxygen as 2, so you cannot make it even, because you multiply 2 and 3, it will become 4 and 6. In this you can make it even. So first try doubling it, 2. Now lead has also got multiplied by 2, so you write 2 over here. So now you write 2 over here. Now the whole thing has got multiplied by 2. Now what happens is that there is 4 nitrogen. So if there is 4 nitrogen and there is 2 nitrogen over here, so instead of making this 2, you rub it. That's why I told you to write with pencil and make this 4. Now you will see that 3 into 2, 6 oxygen, and again into 2, 12. So there is 12 oxygen, and on this side there is 2 plus 4 into 2, 8. 2 plus 8, 10. 10 plus 2, again 12 oxygen. So oxygen is also balanced. Nitrogen is also balanced, lead is also balanced. So the whole reaction is balanced. So the thing is that they'll tell you that we took lead nitrate in a test tube, and when we heated it, it gave a residue and it evolved a brown colored gas, reddish brown. What reaction took place? So this reddish brown colored gas is nothing but your NO2. Nitrogen dioxide is reddish brown in color, and the residue which was obtained is this lead oxide. And oxygen was also evolved, but oxygen being a colorless gas, you cannot see it. So they can give you questions like, what can you observe? So the observation will be, there will be a residue left and there will be a evolution of reddish brown gas, and this is the reaction. You have to write the reaction if they ask you the observation. Anywhere they ask you anything regarding the reaction, You have to give the chemical equation of the reaction. So this is about lead nitrate. Now you would have noticed that in all our decomposition reaction we have used heat. This heat, in ferrous sulfate, in lead nitrate, in calcium carbonate, everything, in every reaction there was heat. And one thing I forgot to mention, in ferrous sulfate reaction you would see that ferrous sulfate is in this form, ferrous sulfate plus 7H2O. Okay, so what actually happens is that it's a two-step reaction. First, ferrous sulfate dot 7H2O breaks into FeSO4 plus 7H2O. That means this green color is nothing but it's imparted by this 7H2O only. I mean, without 7H2O, this ferrous sulfate would not be green. So this green color in ferrous sulfate will change to colorless. And then this ferrous sulfate, when you heat it, this also needs heating. Fe2O3 plus SO2 plus SO3 and balance it accordingly. So it's a two-step reaction. First it loses its water, then it breaks down into this. So my point was, we were having reactions in which only heat used to decompose the reactant. But this may not be the case always. You can have electricity, you can have light, any form of energy it will need for the decomposition reaction. There is one interesting experiment in which you take two carbon electrodes, fill it with water, fill the beaker with water and dip these in the water, immerse them completely. Now take two test tubes and invert them over these electrodes. Connect one electrode to a positive terminal, connect another electrode to the negative terminal of a battery. Now the positive terminal will become the anode and this negative will become the cathode. So this one is the anode, this one is the cathode. Now you see, as you pass electricity, the electricity is responsible for the breakdown of the water in the beaker. And water, you might have heard the term electrolysis of water. This is the same thing. It's electrolysis of water. See, when you pass electricity, this will break up into hydrogen gas and oxygen gas. And these gases will displace the water in these test tubes and will collect over these electrodes. And if you balance this equation, you'll see hydrogen is same on both sides, oxygen is 1 over here, 2 over here. So multiply this with 2 and then it has become 4 hydrogen, so multiply this with 2 So now it's balanced. So you will see that 2 molecules of water will release 2 molecules of hydrogen and only 1 molecule of hydrogen. So when we have, suppose some n molecules of water, they will release n molecules of hydrogen and n by 2 molecules of oxygen. This n has to be an even number, of course. So you see that the number of molecules of oxygen is half the number of molecules of hydrogen. So the gas which is collected on top of these electrodes, the hydrogen gas will be double the oxygen gas, because there is more hydrogen formed and less oxygen formed. So the volume of hydrogen gas will be double the volume of oxygen gas. And oh yes, which will collect on which electrode? You see, oxygen will form the anion, which is O2 minus. Hydrogen will form the cation, which is H plus. So cations move towards the cathode because it's negatively charged. The plus will move towards the minus, obviously. So this cation, hydrogen, will collect over the cathode, and the oxygen will collect over the anode. You can verify this by another simple experiment, that take these test tubes and then bring a burning matchstick near both the test tubes, one by one. You'll see that the anode test tube contains oxygen, and when you bring this near the anode test tube, it will start lighting, it will start burning more strongly, because oxygen is a supporter of burning. That is why. And when you bring this near hydrogen, it will burn with a pop sound, and that pop sound will confirm that it's hydrogen. So they can ask you questions like, what would happen when a burning matchstick is brought near the test tube which was connected to the cathode? Test tube containing the carbon electrode which was connected to the cathode. So the answer will be, hydrogen is collected at the cathode. So when this is the matchstick is brought near this test tube, it will burn with a pop sound. And they can also ask you, why is the gas in one test tube, or the gas at the cathode, double the amount of gas at the anode? So the reason for that is, in the reaction, the number of molecules of hydrogen which are formed is double the number of atoms of oxygen. So the total volume will also be double.